This is a presentation given at a SOFIA TeleTalk in April 2020 on how to use the SOFIA Science Data Archive at IRSA. So just as an overview, there is the link to the SOFIA Science Archive at IRSA. The first thing I'll cover is a very quick start guide. In other words, if you're a current SOFIA observer and you just want to get your data, that'll be the quickest way to getting you launched and running. Then I'll go through more slowly and talk more about how to find specific data on any given either inertial target, in other words, something you can specify with an RA and DEC, or a moving target, in other words, something with an orbit. I'll also show you some highlights from other IRSA tools that have a similar look and feel to the SOFIA Science Archive, and a little highlights of how you can use these IRSA tools to help you plan future observations. The last slide has pointers of where to get more help, including the online help within the tool itself, the IRSA help desk, but also the IRSA YouTube feed. So, quick start. You just want your data. You were a SOFIA observer and you just want your data. So if the data are still proprietary, you need to log in before you can get access to it. In order to get an account, you need to contact the SOFIA Science Center help desk to get access. Then when you're ready and you've logged in, load the tool, search on your PI name, select all the data, and download. It's not too hard. There's the IRSA homepage. There's the icon for SOFIA. Click on it and you get taken to a page that covers all of the SOFIA data at IRSA. In order to get access to the archive, click on that icon. This is what the SOFIA Science Data Archive at IRSA looks like. By default, you're dropped into a position search, but if you just want to get all of your data, what you want instead is an all-sky search. Then click on the triangle to reveal proposal constraints and put in your PI's last name here. Note that partial matching works. In other words, if you type Anders, you'll both get data from Anderson spelled with 2 S's and Anderson spelled with 1 S. Then the last important thing in this context is to get data product constraints set correctly. Do you want all the data? Level 0 is the rawest level of data and level 4 is the highest processing data. Do you want all the data or just the higher level products? Certain instruments don't produce all levels of data, so that might matter. So after you search, you get a bunch of tabs. The very front tab is a list of all the AORs that meet your search criteria. So if you searched on your PI's name, you'll find all of the data from that PI, not just from that program, but from that PI. The red rows indicate proprietary data. So if you are trying to access proprietary data, you do have to log in before you can get access to it. You can select individual rows one at a time, or you click on the top of the column to select all. Then click Prepare Download. Note that I have not logged in, so it's going to deny me access to some data. It's going to say explicitly that this table contains proprietary data and only public data are going to be downloaded. Then click Prepare Download to package up the data. Once it starts, you can send it to the background and regain access to the rest of the SOFIA Science Archive interface. When it's done packaging, you can go into the background monitor and click on individual files to download them. It's going to save the file wherever your browser is configured to save files. If you have lots of files, like I do here, you probably want to turn on email notification. It will email you when it's done packaging, and included in that email is a link to a script that allows you to download and unzip all of the data that it's packaged for you. Now I'm going to go a little bit slower, talking more about the individual choices at each of these steps for a search on any given target. There are 3 main phases to that. Searching the archive, and there's many different ways to search the archive. Then looking at the results, and there are many tools that allow you to explore the results of the search, including previewing the data. And then the final phase is downloading, and you have some control over how the files are packaged. For the rest of the talk, the really important points on each slide are given in red, but hints and tips are given in purple italics. So, searching. The prominent link right underneath the thing that says SOFIA Science Archive is a link to what instruments are included, what cycles are included, including important notes on what data exist and what don't. So there's notes there that you can click on. If you want more generic help on the SOFIA Science Archive, you can click on the help link here. Wherever you are in the archive, if there's a circle with a question mark, that's context-sensitive help. So you can click on that and be dropped into the help at a spot relevant to what you're looking at. So by default, the search is a single inertial position. In other words, something you can specify with a name or a position in right ascension declination or galactic coordinates, whatever you want. Here are examples of all the different coordinate syntaxes that it accepts. You can put in a name or a coordinate in any number of units. Once you start typing in a position or a name, this changes to reflect what it thinks you've entered. Here I've typed in M42. Here it's using NED to resolve the coordinates, and this is the position that it picked. So you can look under the box to make sure that it's understood you correctly. Next, you have to put in a search radius. You need to change the units before you change the numbers, so that if you put in, say, 10 in here, intending to change it to arc minutes, it will interpret it as 10 arc seconds, that when you change to arc minutes, will just simply convert the units. So you need to pick the units first and then put in the radius. If you want to do multiple positions at once, you can choose multiple positions. The file that you need to upload should be IPAC table format, which is basically just ASCII with a header on it. You can load the file from your own disk or from the IRSA workspace, which is a little bit of disk space at our end where you can work. You have to log in to get access to it. Then you need to change the search radius if appropriate, and just like on the prior page, you need to change the units first and then put in the radius. If you want to get solar system targets, you need to choose solar system target. Now you need to put in the object name or the NAIF ID. You need to type slowly in the box, and you need to let it help you. Like if you type in Europa, you have 3 different choices. You need to go slowly enough so that you can pick from this list exactly what it is that you want. If you just hit return, the search probably won't work because it doesn't know exactly which object you mean. So once you put in your target, pick what you want and then look below the box to make sure that it has understood you correctly. When you want to do an all-sky search, that can be useful specifically for pulling all of the data associated with a given PI, but there are other contexts too in which it would be useful. So now let's look at all of the choices on the second half of the search screen. You can click on the arrows to expand them. Proposal constraints is the first one. You can search on the PI or the plan ID. Observation constraints allow you to search on the mission ID, the AOR ID, or the observation date. For instrument constraints, you search on the individual instrument name, and then the menus on the right change based on which instrument that you pick. Or you can search by wavelength range. Data products searches on the data processing level. So level 0 is the rawest level that's produced, that's in the archive, and 4 is the most highly processed, so like mosaics. And you can also choose observation type. So for example, object or sky or dark or flat. Note that not all instruments produce data at all levels. So depending on what instrument you've picked, this might change to reflect the limited choices that are available for that instrument. Now, when you actually go and do the search, this is the kind of results that you'll see. On the left, there's the search results window pane. On the right, there's the details window pane. If you want to change the relative sizes, you can grab and drag the boundary between the panes to change their relative sizes. There are different tabs on the left that provide different insights into which observations it found that matched your search criteria. The AOR tab is in the foreground, but then each of the instruments that you searched on has an additional tab. On the right-hand side, different tabs are providing different levels of information associated with the observation that's selected on the left. So in this case, the details tab is in the foreground. Depending on which tab you are on the right, the data tab will show the actual data, or the coverage will show you the sky coverage. So the AOR tab is the most compact view of observations. You can scroll left and right within this tab to see additional columns. For all of these IPAC tables, they have these table controls at the top. You can go earlier or later among pages of results. So you can change, if you want, the number of observations per page. It's defaulting to 100. Here it found 82 AORs consistent with my search, and so there's only one screen, one page to go through. The next icon is a filter icon, and that allows you to say, filter the results down to include only one instrument or only one target. You can change the table view to ASCII. You can save this table as an IPAC table file. You can change table options. In other words, you can turn off or on columns. You can impose filters from there as well. The double arrow says make this window pane take up the whole browser window, and the circle with the question mark is context-sensitive help. So now I'm going to pick the Axes tab and the Coverage tab. So now I can see the individual observations that it retrieved from Axes on the left, and then an incredibly complicated collection of polygons on the right. Each one of these polygons is a different observation that was retrieved of M42. So you can control the image that's here in a lot of different ways. This right here is a HIPS image. HIPS images are designed to cover large regions of sky. So for visualizing the diversity of observations associated with M42, that's really the right choice. You have a bunch of image controls on the top that allow you to control how you interact with the image. If you'd rather have a FITS image underneath, you can pick a FITS image, or you can pick a different HIPS image if you want as well. The row of tools on the top does basic image manipulation like zooming or adding markers or adding coordinates. You can also overlay DS9 regions, for example. So this over here is the layers icon. And when you're viewing a really popular region like M42, oh my goodness, you really need that layers icon. If you click on that layers icon, it shows you all of the layers that are imposed on the image. In this case, it's so much that you have to scroll up and down to see them all. But you can see here that all of the instrument footprints, all of the observation footprints for all of the instruments are overlaid on that image, all with different colors. So that's part of why that coverage tab is really complicated. So you may want to explore this more carefully. You can click on a row in the table on the left and have it highlighted, that footprint highlighted on the right, or you can click on a footprint on the right and have it highlighted on the left. The whole point of this is allow you to investigate the diversity of observations that you found with your search. For example, did it really cover the region you care about? Are there other relevant observations nearby? But admittedly, in a region where there's a lot of observations like Orion, it can be overwhelming. So you may want to use the layers pop-up to turn off or on the footprints for the different instruments depending on what you're exploring. So the next slide has search results from a target that has many fewer observations, Betelgeuse. So you can see that's much less overwhelming. It's just showing you this is where the locations are of the Axes spectroscopy observations that were done. So now if we look at, say, the Forecast tab and pick the Data tab for the foreground, in this case we're viewing the FITS file associated with that observation. And this particular observation has multiple planes, so you can scroll through the planes of this FITS file. You can manipulate the image based on the tools on top, like zooming out or zooming in, and you can save the image, just that one image, if that's what you want. But for downloading the data, we don't want to use the diskette. We want to use a different approach I'll cover in a little bit. So if I pick the Axes tab and the Data tab, because Axes has a lot of complicated processing, you really do need to pay attention to the product type. This spectrum is still an image, so the tool is displaying the FITS image associated with this product. The tool will display extracted spectra in the future, but at the moment, it displays them as images. Okay, so now you're done exploring the results and you found some data that you want to download. In order to do that, you want to click on the tick box all the way on the left of the column. If you want to select all of the columns in a given tab, click on the box on the top and it will select everything. Then click on Prepare Download. Then you have to make some choices. Title just refers to how this packaging is referred to in the background monitor. It doesn't matter so much for small downloads, but if you're doing lots of big downloads, it is important to pick a different title for each of your downloads, just so you can keep track of where it is in the process. You can pick a different zip file structure. So you can have it structured, bundled into subdirectories, or you can have a flat file structure. The Save As field is the file name that it uses when it saves to disk, and you can choose to save it to your local disk or to the IRSA workspace, and you need to be logged in order to do that. If you have lots and lots of files that are being packaged, you probably want to turn on email notification, because then it will notify you as soon as it's done. But then also in that email, it has a link to a script that allows you to download all of the pieces all at once. This matters a lot more when you have many, many, many zip files in the packaging process. Your computer should know exactly what to do with zip files. It might even automatically unzip it as it downloads it. The script also includes lines to unzip the files. If you manage to get all the zip files and you haven't unzipped them, unzip star.zip doesn't work. You have to do unzip and then escape the wildcard .zip, and then it will unzip all of the files, no problem. Remember that red rows means proprietary data. So if you select those rows, it won't even give you a preview of what the data look like unless you're logged in and have legitimate access to those observations. So more advanced tips, there are many important caveats in the online help explaining what is populated and what is not. So for example, some columns aren't populated in the search results. And for example, things that aren't moving targets don't have an AIF ID. So that column is going to be blank for all of the observations that are pointed observations. Calibration observations may not have a PI. Products that combine many different observations may not have a PI. Some files just won't appear or won't be visualized. So all data levels are not found in all the instruments. Sometimes extracted spectra can be rendered as images, and great data for the higher level products, they're tar files, and so they can't be visualized within the tool. So there's lots of caveats. I encourage you to go check that out. If you're doing lots and lots of searches, when you go to this main search page, everything is anded together. So if you search on, say, data over a particular year from a particular instrument, then you go back and search again without restarting the tool and pick a different instrument, it's going to remember that time constraint. That time constraint is still going to be in there. So you need to make sure that you don't accidentally leave a parameter set on subsequent searches. Filtering is a really, really powerful thing that you can do within the tables. You can weed down very long lists into a much more manageable list, and you can filter both on freeform text or from a set of options. So for example, if we start from another search on M42, but this time asking for all the data, we get a ridiculous number of rows in each one of these filters. So in the forecast tab, I'm going to click on that to add filters. Then I'm going to scroll over until I find processing level. Then if I click on that triangle, I can tell it only show me level 3 products. Then click filter. And then it shows me that there's a filter imposed on the table. You can see there's many fewer observations. Here there were more than 1,500. Here there's only 41 left. And then the filter is shown at the top of the column in the filter box. XEs also has an observation type filter so that you can say, I only want object observations, for example. Forecast, you might want just the images. So if you pick just images and then additionally constrain the spectral resolution to be greater than 20, that's just going to give you the narrow band images. So one of the main advantages to having the SOFIA archive at IRSA is that you can use IRSA tools and SOFIA data and integrate it with all of the other holdings at IRSA. There's lots of other images and catalogs at IRSA, but then through IRSA, you can access all sorts of other images and catalogs from other archives worldwide, but within the same tool. So if you want to see just everything that IRSA has on a given target on the main IRSA front page, if you just type in the name or coordinates that you care about, it will give you everything at IRSA overlapping that position. IRSA Viewer is sort of a more generic version of the main IRSA tool with that same look and feel as the SOFIA archive. So this enables you to compare data from multiple observatories. So if I go to IRSA Viewer, I can tell it what kind of image I want. A FITS image, if I want to create a 3-color FITS image, or a HIPS image. Remember, HIPS images are really good for covering large areas of sky. Then you can say, I want to search IRSA holdings, or I want to use my own image off of disk, or off the web, or out of the IRSA workspace. Then I need to put in a target, just like for the SOFIA Science Archive. It has a place where you can tell it, how you want to resolve the name, and it will echo below the box what it thinks you've said. You need to put in the size that you want, picking units first, and then putting in the number. Then you have to select the data set. If this is the very first time you've ever used this tool, this can be overwhelming because this list is very, very, very long. These filters on the left-hand side help tremendously because it will allow you to weed down the number of programs you have to go through on the right. So if I say I just want to see Spitzer programs, then I click on that tick box and it limits the programs on the right to only be the Spitzer images. So for this, I'm searching on M16 and I want to get data from GLIMPS, which is a survey of the galactic plane done by Spitzer. I also, it turns out, selected WISE, but you don't see this right on the screen snapshot because you would have to scroll to see WISE. So this is what it found for the initial results. So it's given me the 4 GLIMPS images that it found and then the 4 WISE images that it found. It's the same size patch of sky, but you can tell right away it's not oriented the same way. That's because the GLIMPS people calculated their tiles based on galactic coordinates. So in order to get them oriented all the same way, you pick lock by WCS and put north up. And now all of the images are oriented the same way. You can change the color table, you can change the color stretch, you can overlay SOFIA footprints or footprints from a variety of other observatories on the images that you've loaded. You can also load catalogs. So what I've done here is I've told it show me only 1 image at a time as opposed to all 8. Show me just 1 image at a time. Then overlay a catalog. So I picked the catalogs tab and got a 2-mass catalog over this whole region. Then I filtered down the 2-mass catalog on the right so that it only had objects that have a signal-to-noise ratio greater than 10 in all 3 of the 2-mass bands. Then it's overlaid here, and I've made a plot down here, a color plot down here at the bottom. And the way that I changed what was plotted is by clicking on the gears. And you can do simple manipulations between the columns of the catalog in order to plot. All of this is interactive. So if you want to see what source corresponds to that source that you see in the image, if you click on that source in the image, it's highlighted in the table and in the plot. And it goes the other way too. Click on a source in the table, it's highlighted in the image and the plot. Click on a source in the plot and it's highlighted in the table and the image. So in order to get more help, there's the blue help tab that's available in all of the IRSA tools with this look and feel. There is also a PDF linked in from that help. So you can, for example, download the PDF and search within the PDF on a particular term that you are interested in. The context-sensitive help buttons should drop you into the relevant portion of the online help. There is, of course, the IRSA Help Desk, which is linked from the main IRSA page. There's also a YouTube channel that collects a whole bunch of brief tutorial videos about IRSA tools. There's a playlist that collects all of the SOFIA relevant videos into one place. It's not meant to be a playlist like watch all of these from start to finish, but you can look at the playlist and say, oh, these are all of the videos, like a table of contents that are relevant to SOFIA, and then you can pick what you want out of that list to watch. There are also other tutorials that specifically go into, say, the image toolbar in more detail, or how to use some of the other tools at IRSA.